So, same as yesterday, we would like to have the poster presenters standing in line to be prepared to come here. And as a reminder, we all have this, this voting form. Please vote for your favorite poster and put it in the box before the banquet starts so that they can do the counting. Okay. It's the HDMI.
You need adapter?
No, it's HDMI. Our first presenter will be Paolo Renati from the University of Catania, Italy. He has lots to say, but 3 minutes.
Thank you so much. My presentation is maybe not peculiar for the data in the sense that we are concentrated on a very common system, milky water perturbed by temperature. This is very well known. The topic is maybe how, what this kind of perturbation can deliver to our better compression of a liquid system like water. Very quickly, we acquired the spectra at several temperatures, and we make the second derivative just to resolve the two main peaks that witness the existence of two kind of oscillators in the system. As you can notice, we can have an isosbestic behavior that tells us that there are two species that change their ratio in function of the perturbation. So what we did is find the point with the minimum deviation standard, and we call it isosbestic point, divided the area under the spectra in two, on the left and the right of this middle, let's say middle line, calculate the area under the spectra, and try to find if this let's say reaction, that is I perturb the system and I change the species, let's say I change the ratio between the species inside, and we try to check if this behavior can be represented by a Van 't Hoff law. Van 't Hoff law is very commonly used in chemistry. It tells us that the free energy of the system depends on the logarithm of the equilibrium constant. The equilibrium constant, in dependence on which system we are dealing with, can be expressed like the ratio of concentration, the ratio of partial pressures, the ratios. In this case, we utilizes the spectral intensities that are represented by the area. So very simply, if the free energy can be expressed by enthalpy and temperature times the variation of enthalpy, temperature times the variation of entropy, we can reconstruct the fact that this is we can making the exponential of this law, we can just found the equation of a line, and we want just to check if our points can be fitted by this function. The answer is yes, and what we got is that this is very important because the enthalpic terms, that is the difference between the energy difference between these two kind of populations, is constant in the sense it's fixed. The angular coefficient is exactly well defined, and it means that this energy difference doesn't depend on temperature. Now, in accordance to the traditional molecular dynamics, if I represented the liquid by the hydrogen bond network, I cannot explain why. But in a framework of quantum electrodynamics, I can, in the sense that one of the two species is thermodynamically independent in its geometry and topology and free energy of temperature. So we check the last thing and other stuff. We try to see if a self-similar behavior is present in our system. We made just the logarithm of the ratio between the intensity 1 with respect to the total versus log temperature. As you can see, there is a scale-free behavior. So the conclusion of this work is that also in near-infrared spectroscopy, we can find really remarkable signature of long-range correlations, coherence, because many scholars have showed that the coherence is isomorphic to scale-free systems and fractals. And so this tells us that maybe we have to try to shift to a new view of condensed matter, and that takes into account to long correlation mediated by electromagnetic fields. Sorry for late. Thank you so much.
Thank you. This was very good for Paolo. Okay. I decided not to introduce the names because most people say their own name again, so let's keep it quick then.
First of all, I would like to thank Professor Sinkova for giving me this opportunity to give a short presentation of our work concerning probing water structures by simulations. To increase the resolution of near-infrared spectrum, wavelet transform is often used to calculate its high-order derivatives. Then we can see more detailed information. Therefore, wavelet transform is also called mathematical microscope. But still, we cannot see the structure detail. In this presentation, I would like to talk about another approach to probe water structures. That is molecular dynamic simulations, which is also called computational microscope. We performed MD simulations for pure water. According to the type of its formed hydrogen bonds, 9 water species are identified, which are denoted as AMDN. MN here represents the number of hydrogen bonds formed with oxygen and hydrogen atom respectively. And we first compare 3 water models, among which we find this model is the best. Therefore, we use this water model in our simulations. 5 different MD simulations were performed at different temperature for pure water, and based on the MD trajectories, the 9 water species were counted, and the proportion of each species is shown in this figure, from which we can see that A1D1 is the dominant species, and then these 2 water structures and these 2 structures. We also found that the only small fraction of few water molecules contained in these systems. Conclusion: our simulation indicates that the complex of the water structures of the pure water is very the component of the water, pure water, is very complex, and the change of the proportion along with the temperature may constitute a criterion to evaluate the stability of the hydrogen bond in the species. And third, the the analysis of the water species may provide an approach to understand the water-related interaction in biosystems. Thank you for your attention.
Welcome. Go ahead.
Hello everyone, my name is Xiaoyu Cui. I'm from Nankai University. Today my topic is high-dimensional chemometric algorithms for analyzing temperature-dependent NIR spectra. High-dimensional data has been extensively used in many fields. They can not only produced by hyper-handed analytical techniques, but also by different kinds of measuring methods. Temperature-dependent NIR spectra, as example, can generated by NIR spectra under a regular change of temperature. These complex, high-dimensional data require data processing and analysis to extract the hidden information of the interest, particularly water. The commonly used chemometrics like PCA and MCIS have some advantages. More than one model is needed to explain the effect of temperature and concentration, and they are not isolated. Therefore, high-dimensional chemometrics may be more attractive to extracting the effect of concentration and temperature. They can separate the effect and provide valuable physical-chemical information. The commonly used chemometrics NPCA, Perfect, ATLD can be represented in a trillion model. Take the water-ethanol mixture as example. The loadings can show the characteristic of the algorithms. NPCA explains the variance, extracting the mixtured spectral features. And the Perfect and ATLD, however, explore the spectral information of the components, such as water or ethanol. Let's see the scores. Temperature score change almost linearly with temperature, which can be used for quantitative analysis. And the variation in the structural variation in the solution can be revivaled with the score change. The concentration score shows the quantitative analysis of the ethanol, and the interaction between ethanol and water can be revivaled by the score change of concentration. In conclusion, high-dimensional algorithm can be a powerful tool for extracting both the structural and quantitative information from the temperature-dependent NIR spectra. If you have more questions, please discuss later from the poster. Thank you very much.
Good noon, my name is Vladyslav Bozhynov. I am a PhD student from the Faculty of Science from the University of Southern Bohemia in Czech Republic. The topic of my today's presentation is dependency model for visible aquaphotomics. And this topic was created because mainly I have a physical background, but nowadays I'm working on the Faculty of Fisheries and Protection of Waters. So I was needed to somehow to connect these things, and at that time the aquaphotomics was some kind of inspiration for this research. And I started to do the spectrophotometry, and the main goal of this research is to develop easy-to-use system which can predict the values of basic water parameters on the spectral measurements. So I decided to work in visible spectrum, in visible range, because of the price of devices and availability. And in my experiments, I used the spectrophotometer Color Monkey, which can measure the spectra in the range from 360 to 740 nanometers with the step and 10 nanometers. And to
increase the harvested information, I used the reflected spectra from the different color etalons with known RGB values and known spectrum. And I tested, in my experiments, I tested such basic water parameters. And the results from the first experiments you can see here. The main idea was to find the color etalons which represents best the changes in parameter. And we found that the yellow color etalon represents the best temperature changes and the blue one for ammonia changes. But the next step was the multivariate analysis of this data and the creation of regression model. I used the PLSR method for this purpose. And I chose only 3 basic water parameters, pH, EC, and temperature, because this is the parameters of the most interest in such systems as aquaponic, hydroponic, which we have in our laboratory. And I used all experimental spectral data for the creation of the model. And here you can see the residuals of the model which was created. This is just the, it's not the tested, but it's training results, training residuals. And unfortunately for now, it's still in process and the testing results is not so good. This is the main reason why you cannot see it here. And let me conclude. So at this stage, there was created a regression model with excellent training results, but it's still a lot of work ahead to create the system to make it possible. And that's it. As well as I'm strictly limited in time, I'm looking forward to have some discussion with each of you in front of the poster number 14. And I would like to thank for this conference, for this symposium, and for you for your attention. Thank you.
Jelena. Yeah, I don't know if I introduce people, but I have to concentrate, and then it's taking time of your presentation. So,
Thank you. So, me again. I'm going to present a poster actually on behalf of my master students this time, who were actually interested in using aquaphotomics as a potential approach for monitoring of water filtration treatment. This is sort of like a very, very common problem, and what my master students were interested in was to sort of see whether this filtration system that is very, very common in our country does really do something to the water or not. So what we did was to collect the water at each stage after these stages of, let's say, it's not just filtration. Some of these stages are sort of like a treatment. So we would take water before before entering the system. Then after these 3 steps of mechanical filtrations, after reverse of osmosis, we also collected the wastewater from the apparatus, and the final products of the system, sort of like after this polishing process, and after the water was stored in the reservoir. So what we did, we collected the spectra in near infrared, and of course with the raw spectra you cannot see anything, but if you just do the spectral subtraction, you can see that these water are changes and are sort of like changed with each of these treatments in the system, and you can even visualize some absorbance bands. Further, we did the SIMC analysis, which is a classical sort of like analysis to discriminate between different waters, and we had very, very nice separation of all classes with the interclass distance larger than 3. The only interclass distance that was quite low was between the tap water, so the water before filtering, and the wastewater, which is sort of logical because the wastewater is actually the one which was removed. So with this analysis, we had 100% accuracy of classification, and we sort of wanted to just visualize how this water looked like, and for each stage of the treatment, we calculated aquagrams, so you can see how the water before filtration was actually full of ions. Then after this mechanical filtration, how this sort of like absorbance decreases a little. Then after this step and reverse osmosis, we see really large changes in the structure of water. We have lots of now bonded water in it. And as you can see, for example, from these aquagrams, wastewater and this original water are very, very look-like. This is the aquagram for the water after all these steps, mechanical filtration, reverse osmosis, and this polishing process, and after it was stored for some time in the reservoir. So you can see the different storage time sort of like produces some differences in the water. So in this time, with this type of system, we sort of got very, very lucky, because with other systems, for example, for the filtration of water, we could not determine these different phases so nicely. So that would be all. Thank you very much. We'll see you at the poster session.
All the way from Africa, that is what I can say. And in the meantime, go ahead.
Okay, hi, I'm Judi Psarrakis from Stellenbosch University, South Africa. So for this poster, I decided to keep it simple. So according to the South African labelling regulations, spring water should be bottled at the source and is not allowed to be filtered in any way that might alter the chemical structure. So the aim of this study was to differentiate between spring water from different sources. So I obtained spring water from 3 different sources in South Africa. These sources were extremely far away from each other, so each source had a different climate, different soil, and everything. I focused on the 1,300 to 1,600 nanometer wavelength range, and I smoothed the spectra with Savatsky-Goulet smoothing, and I applied SNV and OCS to the spectra. So this is just the principal component that explains more than 99% of the variance. You can see separation in PC1 from the left to the right, according to an increase in pH from 5.1 to 8.5. So the study concluded that NIR spectroscopy is able to differentiate between water from different sources. Aquaphotomics can be used to identify fraudulent bottled water on the market, which is currently an issue in Southern Africa, where water is bottled from fire hydrants and other sources and then sold as mineral water or spring water. For more information, please visit my poster, and I would just like to thank you, the conference, for providing me with a travel grant to attend the conference.
And now I will introduce him, because he's been working for us the whole week. So yeah, go ahead. Go ahead.
Hello everyone, my name is Yuki Nakagawa of Kobe University in Japan. I would like to present my poster about this title. Now, quick and simple detection and prediction methods for bacterial growth are required. So, our final goal is to understand the state and movement of bacteria and to predict subsequent changes by using NIR and aquaphotomics. In this presentation, we tried to identify specific spectral patterns at each stage of bacterial development with fast and slow growth speed. This slide is about sample information and methods. We inoculated for different bacterial strains into mineral water and monitored the bacterial growth. This slide shows results of bacterial growth. In these experimental conditions, Acidoborax and Pseudomonas had a fast growth speed. However, Sphingomonas and Campylobacter had slow growth speed. We used SIMCA and subtracted spectra to classify two growth type bacteria and find differences between them. As a result, high classification accuracy was obtained for all investigated spectral regions. And when observing discriminating power and subtractive spectra of first overtone region of water, common peaks were observed in lag phase. In lag phase, common peaks were observed in shorter wavelength range. However, in log phase had common peaks in longer wavelength range. And when doing assignment of common peaks, we discovered specific protonated water absorbance bands. These results were consistent with the fact proton is very important things for bacterial metabolism. From these results, we got the following conclusions. Thank you very much.
Thank you. Next.
Hello everyone, my name is Danyang Li from Shandong University. Today my presentation title is Quantitative Analysis of Yeast Growth Process based on NIR and Aquaphotomics. Biomass is an important parameter for selecting the termination time to maximize the production. However, traditional methods such as cell count technique and weighing that are tedious and time-consuming. So, a new method is in great need to assure the quality of the production. NIR and Aquaphotomics were introduced in our study to prove its feasibility for biomass determination. Yeast were cultured at 4 bottles for 96 hours. Sampling were carried out at 25 appointments. The reference site were measured at 600 nanometer. Subtracted inter were used to improve the quality of spectra. This is the raw spectra and growth curves. The two regions keep the information about baseline changes. The growth curves of biomass were basically consistent between different bottles. 3 different outlier detection methods were used in our study because the principles are different. So a second trial were conducted on the initial outliers, then 5 samples were recognized as outliers. This is the best model results based on Aquaphotomics. It's very good. In conclusion, LWR model were built on Aquaphotomics for biomass prediction. However, further work will need to be done for inline monitoring the manufacture process in large scale. Okay, that's all. Thank you.
Good afternoon. I'm Jelena Kiselova from Bulgaria, Sofia, Bulgaria Medical University. I'm professor at and head of Department Oral Diagnostics, and I present you our pilot study of mouthwash Yume water. Purpose of this study is investigate the possibility of including mouthwash Yume water in daily oral hygienic care, materials and method. instrument was Aquaphotomics sensor, you see, and 50 patients, 37 women and 13 men, age 25 till 80. First group, control group, without oral diseases, 12 patients, and second group, war group, with gingival disease, 13 patients, with periodontal disease, 15 patients, with oral mucosa diseases, 10 patients. We say healthy gingivitis, periodontitis, and oral mucosa diseases, and Yumebutai. Result and discussions. Water quality, very good, no side effects, very low bacterial contents of Escherichia coli, Enterococcus fecalis, and Staphylococcus aureus. Reported interruption of diseases, early herpes, pharyngitis, laryngitis, conjunctivitis, dermatitis, cheilitis, stomatitis, and others. Beneficial effects of patterns, reduce of compliance, dental plaque inhibition, reduce of gum bleeding, repeat health. Before treatment and after treatment, we show our results. We show aquagrams. Before treatment is red color, after treatments is black color. This is classification and predictance of data. You see different results after treatment by male and before treatment by male. Conclusion, the use of Yumebutai has beneficial effect of the oral cavity of healthy and not healthy patients. Thank you.
Good day, everybody. And today I will be talking about investigation of water structures.
Okay. Alexander is going to give a bigger presentation, a 7-minute presentation, and the one I got was the 7 minutes, so we're changing now to the 3 minutes. Good. Sorry. I didn't get USB drive. Which one?
From presentation.
Yeah.
This investigating.
Good. Start the time again.
So today I'll be talking about investigating water structures of Yunosatu spa waters when mixed in different ratio combinations. The purpose of this experiment was to investigate different and new structures and functions of Yunosatu waters combined together. The materials and methods I used was the XDS device with the rapid liquid analyzer component and with a quartz cuvette cell. The wavelength range for my analysis was from 1,300 to 1,600 nanometers. The sample list included the 3 main Yunosatu waters, bronze water, silver, and gold, which don't have bronze, silver, and gold inside them. They're just called like that because of their functionality. Also, Congo 1 water, which has a ratio of 5 times gold water, 6 times silver, and 7 times bronze water, and Congo 3 water, which has equal amount of the 3 waters, which I used as a control. I also measured purified water as a control and made new ratio combinations, which the gold water ratio combinations, which included just adding 1 part of gold water, silver ratio combinations, adding 1 part silver water and bronze water combinations. Also, other water combinations were made which were close to Congo-free water. Looking at the results, after making a PCA pretreatment, there is a very good classification of data in all the 6 days of the experiment, as all the blue dots samples are actually silver water ratio combinations, and the gray ones are purified. On the top left corner, we can see the waters compared with MIRI-Q, and on the top right, we have the all bronze water combinations after adding each part after adding each ratio on top of the other. The results show that they both have, together with gold water, have vapor-like structures and show similarities, while silver water combinations have more stable transaction between each ratio and have a unique structuring, strong bonded structuring. From the other ratio combinations, they can both again be grouped into one similar to silver water combinations and the other to gold and bronze water combinations. Of course, the ones similar to silver water combinations have most silver water inside them. Also, similarities were observed when looking at ratio combinations between bronze and gold water. In the beginning, they don't share that much similarities, but increasing gold water and bronze water, they begin to look alike a lot more. In conclusion, very good classification according to water type, while gold water and bronze water combinations show a lot of similarities, while silver water has very stably and unique structuring. Thank you very much.
I'm Yurika Nakajima from Osaka Electrical Communication University. I'd like to explain about hydration structure of this polymer, PMEA, investigated by for ultraviolet spectroscopy. Poly-2-methoxyethyl aqueate PMEA shows excellent anti-thrombogenetic property. Therefore, this polymer is used coating material for medical devices. It has been believed water molecules play important roles for the biocompatibility. Since PMEA shows similar DSC results with biopolymers such as protein. This figure shows broadband electromagnetic wave absorption spectrum of water. Water is almost transparent in ultraviolet and visible region. However, large absorption coefficient is identified below 200 nanometers due to the electronic transition of an electron. This region is so-called for ultraviolet of FUV region. In general, measurement of an FUV spectrum is difficult because oxygen and water vapor in air also has intense FUV absorption. In this study, therefore, attenuated total reflection spectroscopy is applied for the measurement. This figure shows FUV spectra of liquid water, dried PMEA, and wet PMEA, respectively. Characteristic FUV absorption for PMEA are drastically changed upon contact with water. This result demonstrates change in electronic state of the polymer change induced by the hydration. Structure change induced by hydration will be discussed in detail. Thank you.
I'm Yuto Sakakibara from Osaka Electrocommunication University. I'm going to talk about hydration structure of polyvinyl state investigated by in situ ATR-IR spectroscopy. It has been reported that water molecules play important roles in medical polymers at the biointerfaces. Our previous studies have revealed 3 different types of water in anti-thrombogenic polymer of polymethoxyethyl acrylate, that is non-freezing water, intermediate water, and freezing water. In the present study, hydration structure of polyvinyl state were investigated by means of attenuated total reflection infrared spectroscopy using a flow trough cell designed for the measurements. A thin film compared with the penetration depth of the near field light generated at the prism sample interface was prepared. Time-dependent spectra during the sorption process of liquid water into a polymer matrix were measured. This figure shows the time-dependent infrared spectra during the sorption process of water. A blonde feature in the OH stretching region gradually increases with the spectral shape variation. This represents hydrogen bond structure change in water induced by the hydration. In the fingerprint region, spectral variations arising from the polymer chain are also observed. In order to clarify the hydration structure, a computational data analysis of multivariate curve resolution was applied to the obtained spectra. This method is assumed linear combination of the products of the spectral waveform for each pure component and corresponding concentration profile. The figure plots the result of multivariate curve resolution. 3 different waveforms in the OH stretching region were identified representing 3 different structures in the hydrogen bonding amongst water molecules and polymer chains. Detailed hydration structures in the polyvinyl state were discussed at the poster. Thank you for your attention.
Jelena, we don't have it. Okay, I suggest to go to the next one, and Nikolai gets his presentation.
Thank you. So, I'm Lewis from St. Stephen University in Budapest, and I'll be talking briefly today about some of our achievements with Aquaphotomics for the authentication of Tokai wine. Now, Tokai wine in Hungary is very respected and widely consumed by the people of Hungary and in Europe in general. Quite recently, it's been globally exported, so there's a need for high quality control and quality assurance measures for this wine. Now, this wine is produced from Butyrice berries, as you can see. That is, the berries have been infected by the mold Butyrice cinerea. This is actually a good infection because it is believed to impart certain taste qualities and organoleptic properties into the wine, which is very much loved by the consumers. However, in as much as In as much as researchers continue to develop advanced methods to track and monitor adulteration and quality assurance in general, the producers also continue to develop more complex methods of adulteration. And in Tokai wine, this is considered as the exclusion of butterized berries in the production of the wine. So we decided to explore the aquaphotomics approach to track this kind of adulteration. So the whole idea was to artificially adulterate 4 Tokai wine up to 4 levels of adulteration based on the sugar concentration of non-adulterated wine. So basically, what I'm trying to say is that we use the sugar contents of these wines as a marker. Now, we prepared 3 repeats of each of the adulteration levels, and each repeat was scanned 3 times, 3 consecutive scans, using millicube as a reference. Now, in order to extend the scope of our study, we decided to use 2 different kinds of NIR, that is the handheld and then the benchtop. So from the results, we can see a very nice separation in PCA for the benchtop instrument, and we can also see an increasing pattern of adulteration from C1 to C2, C3, C4 in the aquagram. So basically, we could say that the aquaphotomic approach was very effective in determining this kind of adulteration. Similarly, for the handheld instrument, we had a better separation in PCA actually compared to the benchtop, and similar trend in the aquagram. We also arrived at a very good regression module with the coefficient determination that was very good and quite good enough to predict this form of adulteration with a good accuracy. We can also see from the regression vector the most important bands that were very crucial in determining this kind of adulteration with the aquaphotomic technique. Similarly, for the handheld device, we had quite similar results exactly. So all what I've been trying to say is that the aquaphotomic approach is a groundbreaking technique that is capable of determining and tracking adulteration into Cai wine, and it can be extended to wines of similar quality. Thank you very much, and this is our team.
Thank you. Thank you. Hello, everyone. I am Michias Nomura of DHC. My poster title is Characterization of Izu Akazawa Deep Sea Water by Aquaphotomics. We are pumping deep sea water called DSW from the depth of 800 meters of Izu Akazawa in Shizuoka Prefecture, Japan. Key water of DSW is sunlight. DSW is deeper than depth of 200 meters, which sunlight doesn't reach. So DSW is low water temperature. And as the primary producer, phytoplankton doesn't grow. So biomass containing microorganisms is few. So DSW is cleanliness. Because there is no phytoplankton in DSW, inorganic nutrients such as nitrogen and phosphorus necessary for the growth of phytoplankton are not consumed by phytoplankton. So much inorganic nutrients remain in the DSW. Finally, due to the different water temperature of DSW and surface seawater called SSW, DSW doesn't mix with SSW. For that reason, the quality of the DSW is stable. In order to investigate the characterization of DSW, we analyzed the water molecule structure of DSW and SSW by Aquaphotomics. PCA was performed for 1,300 to 1,600 nanometer, which is the first overtone of the water. And water spectral patterns were compared using the aquagram. As a result, there were differences in each structure between DSW and SSW. DSW and SSW. So, sorry, this is factor 1. In addition, it was found that DSW has a less hydrogen bonded water. And and SSW has strongly hydrogen bonded water structure. On the other hand, free water assigned to 14.8 nanometers is not difference between both seawater. Thank you.
Miyaguchi. Yeah. That's the point. Miyaguchi. Oh yeah. The new one. You meant the new one. Yeah. This one pointer. Yeah.
Hello everyone. My name is Kaori Miyaguchi. We, Aizoro Technical Company Limited, develop building materials specializing in aqueous waterproofing seal to provide civil construction companies such as a bridge, a tunnel, and a road as well. Today, I'm here to introduce you why we use the functional water for the construction work. Okay, thank you. This way. Enter. Here. Enter keys here. Okay. So, as we provide the waterproofing aqueous sealer for motorway, it's supposed to be done in a daytime work, but because of the delay of the pre-working, we have to do it in the night time. As you know, we use for the aqueous sealers. It's very hard to concrete. It's hard to dry in quick way. So we are desperate because we did it in the daytime. So we tried various methods, like increasing the amount of AIS in the cement and adding special liquid with quick action and so on and so on. And finally, we found a solution. We could shorten the application time to 1/3 time than usual using the mixed functional water and charcoal powder. Okay, thank you. Okay.
It's 2 times.
Okay. Yes. This is the appearance of the waterproofing work. Have you ever seen the inside of the paved asphaltment? No. So we can show you the section, the cross section. It's here. Usually, this is a basement, it's a concrete slab. And over that, the conventional way is to apply asphalt liquid and salt, silica sand, and finally apply the asphalt. That is the ordinary way. But our company, we used another 2 layers to fortify the basement, to have a long life of the motorway. So that is a concrete slab. Usually, it remains like that, but we put in this high-spec seal liquid that is very, very good for filtrating to the tiny cracks. So we could have the durability for long life overload. And on that layer, we put high-spec seal L and P. L means liquid, P and powder. Okay, in powder. And that is, we put in here, we mix the charcoal and water, and mix well and spread. So this is a functional water aquagram. So maybe you can understand why it's dry up so quickly, because you see it's obvious, it's a lack of disperse, and this was much of hydrogen. So that's why it's to depart from the molecule. So it helps us to dry it quickly. We would like to deepen our understanding of water structure and its characteristics to improve our products and meet customers' requests. But we don't know yet much of them, so we are really appreciated to have your advice and suggestion. And for the aquagram, you should ask to the Dr. Zoltan, please. And our goal is to make everyone realize the importance of water and its unlimited possibilities for our better future. Thank you very much, and I'm waiting for you at our poster 28. Thank you.
So apologies for Nikolai. It's somehow it was deleted, so I must have done it. So you can. He's now gonna take serious measures, make sure it's on there. So go ahead.
Okay. Yeah, so. Okay, thank you very much. I'm not going to take much of your time here before lunch. So my name is Nikolaj Sorgenfrey Blom. I come from the Technical University of Denmark, and I'd like to present a concept poster today that we call the Water Bridging Initiative. Here you see a beautiful Japanese water bridge. The water bridge we normally work with is this floating water bridge, which is a demonstration of the magical features of water. I can tell you more at the poster. We work with descaling of drinking water, disarming resistant microbes that I will talk about tomorrow, and also with liquid crystal properties of water. My journey into the water world has been inspired by these beautiful people. Professor Montagnier says DNA is a wave. Vicello says in a coherent sea. Giuliani, where water is key, and Professor Pollack, and somewhat EC. And we know the future is near. So we have assembled a wonderful team in Denmark consisting of 3 scientists and 3 students, and we call ourselves the Water Bridgers, of course. And we work in a transdisciplinary and collaborative way. And as Professor Chenkova mentioned yesterday, we believe that the new water science is a discipline that bridges many of the traditional disciplines, and that's the only way we can move forward understanding this holistic magic of water. So we were fortunate to be funded by a private Danish foundation called the VILLUM Foundation. They produce a lot of windows, and they give out a lot of money to unconventional research. Very grateful for that. We received 2 grants so far for studying bacteria, I will talk about tomorrow, and structured water that I will talk about at the poster if you come and see me, and also a descaling device that we have characterized. And these are some posters that I will not show you more about. And I will also say that we are very interested in communicating science. We have been part of a documentary film that I will be happy to share with you if you're interested. It's called When You Look Away. And we believe that communication of science is extremely important, and especially in an upcoming field like water science and aquaphotomics. So my poster is number 23, and I would like you all to come and attend at the poster session, and let's unite all our efforts. Thank you very much.